Hi, my name is Javier Ramirez, and this is my Humans Factors report on Mars gravity. Mars gravity is an issue for any mission that is to be carried out on the surface or low orbit of Mars. Problems that arise from Mars gravity are space motion sickness, which is similar to car sickness or seasickness. And the reason that this happens is because the human brain has learned how to process signals about the position of the body in relation to the world around it. And the sudden input of many conflicting body signals confuses many astronauts and causes them to feel sick. Deconditioning is also a big problem, and deconditioning is the weakening of physiological systems. On Earth, the heart operates against gravity to keep the blood flowing properly, and under low gravity, the heart has to slow its pace in order to keep an equilibrium between the body and the world around it. Slower heart rate results in decreased heart size and diminished blood volume. The musculoskeletal system is also affected because uh, lower gravity reduces weight bearing and it leads to lower levels of calcium and nitrogen and phosphorus in the bone, which decrease bone size and volume. During missions in the Mir space station, it was found that 1.2% of bone mass in the lower hip and spine were lost per month in microgravity environments. Decreased muscle tone and strength, weakened reflexes, and decreased tolerance for physical work are also negative effects of lower gravity environment. Now, the causes of these problems is that in space, human systems uh, that have evolved with Earth's gravity function very differently because humans have grown and gotten used to Earth's gravity. So if once they're taking into a different environment, the body has to work really hard to adapt. Uh, your body doesn't know the orientation of because of itself because it has no weight, and you can't feel or sense where you are. In space, your body becomes confused by the sudden change in what it has learned to expect. Mars' surface has one-third the gravitational force of Earth, and long-term exposure to Mars gravity can be as harmful as long-term exposure to microgravity. Solutions and strategies that we could use to alleviate the effects of Mars gravity are space sickness that usually goes away after a few hours, so that really doesn't need anything. Maybe some medicine we could send with the astronauts, and as long as the spacecraft contains a carefully controlled atmosphere to enable normal breathing, adequate temperatures, and sufficient shielding to guard against space hazards like radiation and meteors, humans can survive under microgravity conditions. Exercise and nutritional supplements are currently used to help counteract some of the negative effects of zero G, to keep the astronauts healthy and fit. Artificially produced gravity is also one of the best strategies to alleviate microgravity effects. Artificial gravity can be produced by either rotating the entire vehicle or including an onboard centrifuge, but the only problem with that is it takes a large shift or craft to actually have artificial gravity. Um, the effects of prolonged exposure to Mars gravity are still unknown, so there isn't really many strategies that we have right now for alleviating the effect of Mars G on the surface. Yeah, thank you for watching this video and hope this helps.